Welcome to Brain Vision.
In this problem, two smooth disks A and B with identical mass are moving with different velocities before they collide. We want to calculate their final velocity just after the collision. Let's first look at the horizontal components of the momentum, and we know that these must be conserved. So the conservation of momentum tells us that the initial momenta of the two disks before the collision must equal to the final momenta of the disks after the collision. So initially, the disks have momenta. Disk 1, its mass 0.5 times its x component of its velocity, which is 4 cos theta, which is 4 times 3 over 5, minus the initial velocity of disk B, or disk A actually, is minus mass 0.5 times the x component of its velocity, which is simply 6 meters per second. After the collision, we have that disk B has momentum 0.5 VB2 in the x direction, plus the momentum of block of disk A, which is 0.5 VA2 in the x direction. And so essentially we have an equation there with two unknowns. So now that we've used the conservation of momentum, let's look at the definition of the coefficient of restitution. The coefficient of restitution, E, is equal to VA2, the velocity of A after the collision, minus the velocity of disk B after the collision, over the initial velocity of disk B, VB1, minus the initial velocity of disk A, VA1. And this coefficient is given, so E is given as 0.75. We just substitute our values in here, and this is VA. So again, we'll use horizontal components, and we'll take the right direction as positive. So the horizontal components VA 2x minus VB 2x over 4 into cos theta, which again is 3 over 5 minus 6. Since disk A is moving to the left, and hence its velocity is negative. So now we have two equations from our conservation of momentum and our coefficient of restitution with two unknowns. And so we can solve these two equations simultaneously and find the final component, the final x component of A's velocity to be 1.35 meters per second, and that's to the right, and the x component of disk B is 4.95 meters per second, and that's to the left. Now we need to calculate the y components. So we'll take the upward direction as positive, and we'll use the conservation of momentum again. mv1 is equal to mv2. So in the y direction, we have for disk 1 0.5 times sine theta, 4 over 5 times v, which is 4 meters per second, and disk B has no y components. Now this must equal to the final y component of B, which is 0.5 VB 2y. So if we rearrange this, we find that VB 2y, the y component after the collision for disk B of the velocity is 3.2 meters per second, and that's upwards. Now we can write our final velocities for A and B. So the final velocity of A is simply 1.35 meters per second to the right. It only has a horizontal component, whereas VB has horizontal and vertical components. And so VB, to calculate the magnitude, we take its x and y component and square root the sum of their squares. So that's 4.59 squared plus 3.2 squared, and all that under the square root sign. So VB has a magnitude of 5.89 meters per second and an angle theta, which is the arctan of its y component over its x component. So that's 3.2 over 4.59, and hence theta is equal to 32.9 degrees.